All right, assignment 3.1. So we want to answer the questions, where is it concave up, where is it concave down, and where's the point of inflection? So if I look at number 1, it's concave up all the way to here. So from negative infinity to positive 1, it's smiling. Where is it concave down? So from positive 1, it's concave down for the rest of the graph. So from 1 to infinity, it's concave down. And then where's the point of inflection? So that point where it changes concavity, and there's your answer. For number 2, look off the graph. The first part of the graph is concave down. That's negative infinity to negative 2. Oops, I want to do concave up first, sorry. So what part of the graph is concave up? From negative 2 to positive 2. And then B asks for concave down. That's negative infinity up to negative 2. That's positive 2 to infinity. And then there are no points of inflection. So where the concavity changes is at an asymptote, not at a point. Number 3, concave up all the way up to negative 1. It's also concave up this little section in here. That's 0 to 1. It's concave down. This little section here is concave down from negative 1 to 0. And then it's also concave down from positive 1 till forever. Points of inflection, where does it change? Concavity. So at negative 1 is a point of inflection. At 0, 0 is a point of inflection. And at 1, 1 is a point of inflection. So we have 3 points of inflection for number 3. Number 4, it's concave up from negative 2 to 1. It's also concave up from 4 to 6. And it's also concave up from 8 to 9. It's concave down only here. From 6 to 8, it's concave down. A line has no concavity. And then where are the points of inflection? So where does it change? It has 1 point of inflection, and that's there at 6, 1. Number 5, it says show organized steps, and we're going to answer the same questions for number 5, but not off the graph. So we have 6x squared minus 4x cubed. I need to find the first derivative. That's 12x minus 12x squared. Then the second derivative, which is 12 minus 24x. And then make this equal to 0 and solve it. So I'm going to add 24x and divide, and I get 1/2. Now, draw a second derivative number line. That's at 1/2. Then plug into the second derivative. So like plug in 0, and you can see the answer is positive. Plug in like 2 or 5 or 100, and the answer is negative. So that means this is concave up from negative infinity up to 1/2. It's concave down from 1/2 to infinity. And then we have a point of inflection at 1/2. And then you would plug that 1/2 into the function and then calculate it. I'll do it for you. And that actually gives you the answer 1 when you plug in 1/2 into there. Number 6. We have a function. We're going to go through the same steps again. So step 1 is to take the first derivative. Then the second derivative. Make it equal to 0. Oh, did I do the wrong one? I did do the wrong one, didn't I? X to the fourth minus 4x. No, I did the right one. So it's 4x. This should be 12x squared minus 24x. It almost looked like the other one, right? But it's 12x squared minus 24x. All right, I got this. Factor out 12x. That's x minus 2. So the two solutions are 0 and 2. Now draw a number line for 0 and 2. Plug in a number into the second derivative. A negative 1 gives you a negative times a negative, which is positive. Plug in positive 1. That's a positive times a negative, which is negative. And then plug in a number bigger than 2, like 3 or 5 or 10. That's a positive times a positive, which is positive. So this is concave up from negative infinity up to 0 and 2 to infinity. This is concave down from 0 to 2. And then the point of inflection. So at 0, there's a point of inflection. That gives me the answer 2. And at 2, there's a point of inflection. And then at 2 gives me the answer negative 14. All right, number 7. A little trigonometry. Step 1, and it's from 0 to 2 pi. Okay, so we want to find concavity here. So the first derivative, the derivative of cosine is negative sine. The derivative of sine is positive cosine. Then I have to do it again. So the second derivative, the derivative of sine is cosine, but it's negative because it's negative already. And the derivative of cosine is negative sine. So there we are, equal to 0. I can divide out by negative 1. When I solve this, you would get this or this. Both are fine. And so where on the unit circle do they have the same value, but one's positive and one's negative? So there's only two spots that have that. So this is a point and this is a point. So at those 2 points, they have the same value, but one's positive and one's negative. So that's a 45-degree reference angle. This is in quadrant number positive, negative, quadrant number 4. So this is 7 pi over 4. This is negative positive. This is in quadrant 2. So that's 3 pi over 4. So at these two values, we have points of inflection. Draw a number line. So I'm going to put 3 pi, this goes from 0 to 2 pi. So they're endpoints. So this is 3 pi over 4, and this is 7 pi over 4. I'm going to try to pick angles at an axis if I can. So for 3 pi over 4, I can pick pi over 2 into here. At pi over 2, the point on the unit circle is 0, 1. So sine is 0. This is positive 1, but it's negative in front, so this is negative. I'm going to pick pi for the next one. That's negative 1, 0. So cosine is negative 1 times negative is positive 1. And this is 0. Anyways, the first one actually, this was 0. And this is negative 1 to give you negative 1. This is going to give you the answer that's positive. And then the last one's going to give you an answer that's negative. And so it's concave up from 3 pi over 4 to 7 pi over 4. It's concave down from 0 to 3 pi over 4 and 7 pi over 4 to 2 pi. And the point of inflection is at 3 pi over 4 and 7 pi over 4. Now, if I plug in 3 pi over 4, one's positive and one's negative, it's going to give you the answer 0. And if I do the same for 7 pi over 4, it's the same value, but one's positive and one's negative. So when you combine it together, the answer is 0. That's where the point of inflection is. All right. I know. Number 8. This one's easier. All right, so take the first derivative. That's 15x to the fourth minus 20x cubed. The second derivative is 60x cubed minus 60x squared equal to 0. Factor out a 60x squared. And the two answers are 0 and 1. So when I do a second derivative number line for 0 and 1, 0, if I plug in a negative number, I get a positive times a negative, which is negative. If I plug in a half, I get a positive times a negative, which is negative. And then if I plug in a number bigger than 1, it's positive. Notice the even multiplicity keeps the sign the same. So we have a point of inflection right here. So it's concave down from negative infinity all the way to 1. It's concave up from 1 to infinity. And then the point of inflection only at positive 1. And if I plug positive 1 in, I get negative 2. Number 9. The first derivative and the second derivative. It's blurry. See if I can clear it up. So 2/3 times 1 in front, subtract 1. The derivative of negative 3 is 0. Negative 1/3 times 2/3, multiply the tops and the bottoms. And then subtract, and you get negative 4/3. I'm going to make it equal to 0. I'm going to write it calculus friendly. So we have negative 2 over 9. The denominator would be the cube root of x to the fourth. Now, there's nothing that makes that equal. So if I look at the numerator, equal to 0, there's no variable there. You can't solve it. So we have no point of inflection at all. But we do have a value here. So because the derivative is undefined, we have no point of inflection. We do have a value that x cannot be for the derivative. So x can't be 0. That would make it undefined. So when I draw a number line, I need 0. And then when I plug in here, no matter what number I plug in, the answer is always going to be negative. So this whole thing is concave down. And it's never concave up. And we have no point of inflection. All right, number 10, back to trigonometry. We'll do it together. So we have a function from 0 to 2 pi. I need to take the derivative. So that's the derivative of sine is cosine. So it's negative 2 cosine x. 2 times a half is negative 1x. The derivative of 2x is 2. Take the second derivative. So the derivative of cosine is negative sine. So a negative times a negative makes it positive 2 sine x. The derivative of negative x is negative 1, and that's equal to 0. And the derivative of 2 is 0. So we're going to solve this. We're going to add 1 and divide by 2. So the y-coordinate is 1/2. So it's either root 3 over 2 or negative root 3 over 2 and 1/2. So this is a 30-degree reference angle. This angle on the unit circle would be pi over 6. This angle, negative positive, would be 5 pi over 6. Now we're going to draw a number line with those numbers for number 9 or 10. So from 0 to 2 pi, we have pi over 6 and 5 pi over 6. So if I pick an angle here, like pi over 2, at pi over 2, sine is positive 1. So 2 take away 1, that would be a positive answer. The multiplicity makes those signs change. And then we have a point of inflection at pi over 6 and at 5 pi over 6. And then you would plug that into the function to get your answer. I'm not even going to make you do that. I'm going to do this. Kind of cheating. So there's the point of inflection, and you'd plug in pi over 6, plug in 5 pi over 6 for it. It is concave up from pi over 6 to 5 pi over 6. It is concave down from 0 to pi over 6 and 5 pi over 6 to 2 pi. All right, number 11. All right, so take the first derivative. Take the second derivative. Again, you can press pause if you want to do it yourself, right? Or work with me. Make it equal to 0. The only answer is 0. This is monotonic. It only has one concavity. So if I plug in a positive number or a negative number, it's only concave up. So we have no point of inflections, and it's only concave up. Number 12. For this one, we're finding maximums and minimums using the second derivative test. So let's practice that right now. So first I need to find the critical numbers. So take the derivative, make it equal to 0, and we're going to solve it. So I'm going to factor out 3x, and then I'm going to solve it and find the two critical numbers are at 0 and positive 2. We're then going to take the second derivative, so that's 6x minus 6, and we're going to plug the critical numbers into the second derivative. So if I plug in 0, I get a negative answer, which means it's concave down, which means it's a maximum. At positive 2, I get 12 take away 6, which is positive, concave up, which means it's a minimum. So we have a relative minimum at 2, and then you'd plug it in here, and you get the answer negative 2, negative 1. What do I get? 2, right? And then you'd have a maximum. You'd plug in 0 and get the answer 6. Number 13. A new way to find maximums and minimums. So the first derivative is negative x cubed, and then multiplying it's 9x, and that's it. The second derivative is negative 3x squared plus 9. When I solve this, I get the answer positive and negative root 3. Oh, I didn't want to do this part. Let's try this again. I need this, but not this part. This is what you make equal to 0. So factor out a negative x squared. Nine over 2. Oh, this should be x cubed, right? So factor out a negative x only. There it is. All right, now I'm on track, maybe. And then a difference of squares. And then I'm going to find my critical numbers. So my critical numbers are 0, positive 3, and negative 3, because that's what makes the first derivative equal to 0. And then into the second derivative, I want to know if the answer is positive or negative. So 0 gives me a positive answer. Concave up, it's a minimum. 3 and negative 3, because you're squaring, they give you the same answer. And that answer is negative. So that's a maximum. So we have a relative minimum at 0 and 5. And then I'd let you use a calculator for this. So if you plug in positive or negative 3, because you're squaring and forth, it'd be the same answer. And that answer is 101 over 4. Enough, right? Number 14. In number 14, you have a function from 0 to 2 pi. Take the derivative, that's 2 cosine x, make it equal to 0. So at what angles is the x coordinate 0? So that's up here at pi over 2, and down there at 3 pi over 2. Then find the second derivative. The derivative of 2 cosine x is negative 2 sine x, and then you plug in the angles. So if I plug in pi over 2, the value of sine at pi over 2 is positive 1, times negative 2 is a negative, so it is concave down, which is a maximum. And then at 3 pi over 2, it's negative 1, so a negative times a negative is positive, so it's a minimum. It's concave up. So this is at pi over 2, and if you plugged in here, you get 2 plus 3, which is 5. And then 3 pi over 2, if you plugged in here, you'd have negative 2 plus 3, which is 1. So the maximum and the minimum. Number 15. We're going to make it calculus friendly right away. Take the first derivative. And I want you to notice that if I make this calculus friendly, there's nothing that makes it 0, but there are 2 answers that make this 0. So if I take x squared plus 2 equal to 0 and solve it, well, there's nothing there, is there? Oh, do you know what I forgot? There's a hook. So when I take the derivative here, there's a hook of 2x, right? There's a hook there. So if I write it calculus friendly, the 2's cross out, but I still have an x up here. So the denominator's fine, but the critical number there, looking at the numerator, is 0, makes this 0. Now, the second derivative. So for the second derivative, I need the product rule. So just to remind myself again, this is just 2 and x squared plus 2 to the negative a half when I simplify it. No, the 2's cross out. This is just x and then x squared plus 2 to the negative a half. And so the first times the derivative of the second. And then don't forget the hook, plus the second times the derivative of the first, which is 1. So I'm going to make it calculus friendly to make it easier to work with. So again, the 2's cross out. So I have negative x and x squared. So that's negative x squared. And then in the denominator, I have x squared plus 2 cubed, and it's the square root of that. And then this is 1 over the square root of x squared plus 2. Now, that's the second derivative. When I plug 0 into the second derivative, I just want to know if the answer is positive or negative. So 0 gives me 0. 0 gives me a positive answer, so it's concave up, so 0 is a minimum. So we have a minimum at 0, and if you plug that in, that's the square root of 2. So it's 0 and the square root of 2, there's a minimum. I know. We're good. Turn the page. Number 16. So it says the critical numbers are negative 3, 1, and 3. And then the second derivative of negative 3 is a negative answer. That's concave down. So there's a maximum at x equals negative 3. The second derivative at 1 is 0, so that's nothing. And then the second derivative at 3 is a positive answer, concave up, so that's a minimum at x equals 3. Number 17, that's what we're looking at. So our critical numbers, the first derivative at negative 2 and 0 and 4 all equal 0. So negative 2, 0, and 4 are critical numbers. And then when I look off the number line, you won't find negative 2 here, but negative 2 is here, less than negative 1, so that's positive. So you have to know how to read a number line. So that means there's a minimum at x equals negative 2. When I look at the second derivative at 0, where is 0 here? It's in the middle of the number line. It's negative where it is on the number line. That's a maximum at x equals 0. And then the last one is at 4. So look off the number line. Is it positive or negative where 4 is located? So 4 is here. So it's positive where 4 is located. That's concave up. That's a minimum at x equals 4. All right, number 18. Without using a calculator, find maximums and minimums and points of inflection, and then sketch a graph in terms of what we're doing. So we have 2x cubed minus 3x squared minus 12x plus 5. So I'm first actually going to find the end behavior. The power term is x cubed, 2x cubed, which means the right end goes up and the left end goes down. The derivative is 6x squared minus 6x minus 12 equal to 0. And I'm going to solve that. That's 12x minus 6. So at 1/2, we have a critical number. The second derivative is 12x minus 6. When I plug in a half, look, make sure. What did I do wrong? Oh my gosh. Okay, let's try this again. So I want to solve this. This is good. This solving was bad. Divide everything by 6, and you have x squared minus x minus 2. Factor it and solve it. So our critical numbers are positive 2 and negative 1. If I plug them into the second derivative, this is a minimum, and negative 1 gives you a concave down, which is a maximum. So we know we have a minimum at 2, and then you'd plug it into here, and 2 gives you the answer negative 15. And we have a maximum at negative 1. Plug that into the function, and negative 1 gives you the answer 12. If I solve this equal to 0 and add 6 and divide by 12, at 1/2 we have a point of inflection. So if I plug in a number smaller than 1/2 or bigger than 1/2, it's concave down and then up. So we have a point of inflection at 1/2. And then you take 1/2 and plug it into the function to find the y coordinate. And if you did that, it would be at negative 3 over 2. And then you put all of that information together and then sketch the graph. So I'm going to do that right here. So we have a minimum at 2 and negative 15. We have a maximum at negative 1 and 12. And then at 1/2 and negative 1.5, we have a point of inflection. Now, we know the beginning part of this graph is concave down, and then it's concave up. So don't worry about the x-intercept. So there's the shape of it. We have our maximum or minimum or point of inflection. The right end goes up, the left end goes down, the concavity matches, and you just sketch the graph. Number 19. For number 19, the function is 4x cubed minus x to the 4th. So the derivative of that is 12x squared minus 4x cubed equal to 0. I'm going to factor out a 4x squared. So that's 3 minus x. That's it. So the answers are 0 and 3. Make sure I did that right. Good. I'm going to do the second derivative. I mean, it's good to know where it's increasing and decreasing too, so I guess I should do this for the first derivative. So 0, if I plug in negative 1, I get a positive times a negative. And the multiplicity means the sign is going to change the same. Plug in a number bigger than 3. So if I plugged in negative 1, it's a positive times a positive. And then the sign is going to stay the same. Plug in a number bigger than 3, like 5. And 3 take away 5 is negative times a positive. So we only have a turning point there. 3 is a maximum. And then plug that into here. And 3 gives you the answer 27. I might sneeze. I may not. The second derivative is 12x squared minus 4. The second derivative is 24x minus 12x squared. Factor out a 12x, and you have 2 minus x. So now the two answers are 0 and 2. I'll do the second derivative number line down here for 0 and 2. So if I plug in a negative number, a negative times a positive is negative. Plug in positive 1, and then the multiplicity also, the signs are going to change as you go across. So we have points of inflection at 0 and 2. So 0 is a point of inflection, not a turning point. If I plug in 0, I get the answer 0. And at 2 is a point of inflection. So if I plug in 2, I get the answer 16. All right, so I'm going to summarize what I'm going to graph right now. So let me just put this down. So this tells me increasing and then decreasing and then concavity. And then the points that I need to put down on the graph. So I have 2, 3 and 27. I'll put that at the top of my graph. I also have 2 and 16. And 0, 0. And then I'm going to put those points together. So the first part of the graph is concave down, but increasing. So there's concave down and increasing. Between 0 and 2, it's concave up and still increasing. Between 2 and on, it's concave down. So it's concave down with the maximum here. I want you to notice that our power term for end behavior was negative x to the fourth. So both ends are going down. And you have the point of inflection. So the point of inflection and the maximum turning point, and you have the whole graph. Number 20. Use the following information to sketch a possible graph of the function. So we have f at -1 equals 3, f at 2 equals 0, f at -2 equals -1, and the derivative at 2 does not exist. And it says that it's a continuous function, so that means there's a sharp corner or cusp there. So step 1 is just to plot these points to begin with, and then I'll connect them. So -1 and 3, 2 and 0, and -2 and -1. And then the concavity part. So it says the first derivative, it increases and then decreases and then increases. So at -1 is a maximum and at 2 is a minimum. And then the concavity. So -2 and +2, the concavity changes, but then it doesn't change. So here at -2, the concavity changes. So it's increasing. So it's concave up and increasing. Then it changes. It's still concave up, but then it's going to up to -1. And then it's going to decrease. Let me look again. So up to... So what point is it? So here's -1, sorry. So it's concave up here, and then it's concave down. So concave up, concave down, and it's increasing. And it's concave down to 2. And then after 2, it's still concave down, but increasing. So let's see if we can follow this. So this increased up to -1, right? And then it decreased to 2, and then it increased. It was concave up, concave down, and again concave down. This created a cusp, so the derivative of 2 doesn't exist. And there's your graph. Take some practice. 21. Use a calculator. I like a calculator to determine if f at x equals 4x cubed plus sine 5x is concave up or down on the interval including x equals 0.523. So what we need to do is find the second derivative at 0.523 and see if the answer is positive or negative. So how do I do that? So press menu, calculus, and we want derivative at a point, and the value is 0.523, and this part needs to be the second derivative. So change that to the second derivative, and then press enter, and then you type in 4x cubed plus sine, what we got, 5x. I see the answer is negative, just making sure. So that means it's concave down. And that's using our calculator to see concavity. 22. Find the absolute max and minimum. See if I remember how to find absolute max or minimum on this interval. So I'm going to take the derivative and make it equal to 0. I'm going to solve it. And I get the answers 0 and 1. Next, I'm going to do a table of values. And I'm going to use the ends and these numbers. Make sure 0 and 1, both of them are good. Making sure I solved it. Did I do it again? I think I did it again. So you can only factor out 4x, so it's 4x squared. How does that change it? That means the answer could be positive or negative 1, right? If I did this right. So it could be either one. So those are all the numbers. Positive, negative 1, 0, and negative 2. So the critical numbers and the ends, and each one we're going to plug into here. So negative 2 gives you the answer 8. 0 gives you 0. Negative 1 and positive 1 give you the same answer, which is negative 1. And so looking off here, what wins for the absolute max? And the answer is 8. What wins for the absolute minimum? And the answer is negative 1. 23. Find the C value for the mean value theorem. What's the mean value theorem again? That's when IROC equals AROC. So I'm looking at f at x equals the square root of x minus 2 from 2 to 6. So it is continuous, and you can take the derivative from 2 to 6. Or can you? Because it's okay, the ends. Yeah. All right. So if I take the derivative here, calculus friendly, so the derivative then is 1/2 x minus 2 to the negative 1/2. And if I write that calculus friendly, this is what it would look like. And then I need to do the AROC on the other side. So AROC is, I need to plug 6 into here. The square root, 6 take away 2 is 4, and square root of 4 is 2. Plug 2 in, and you get 0. And then you subtract. So that's 4. So that gives me the answer 1/2. So right away, I see 1/2 can be divided out. So I have 1 over the square root of 2 equaling 1. So that means x must equal 3. Because 3 take away 2 is 1, and 1 divided by 1 is 1, and there's your answer. That's the value. 24. It's good to have good algebra skills, right? the graph y equals ax cubed plus bx squared plus cx plus d has a point of inflection at 0, 2 and a relative maximum at -1, 4. And then it says find the values of a, b, c, and d. So the first thing I'm going to do, if I plug in 0 for x and 2 for y, right away you know that 2d equals 2. If I do again for 4 and I plug in -1, so I already know d is 2, so I can plug that in. I get -a, -b, -c plus 2. Subtract it. Take the derivative. And then I'm going to plug in the max. So I'm going to use the x value. So it's equal to 0 when x is -1. That's the definition of a maximum. And then plug in -1. So I get 3a minus 2b plus c is equal to 0. I'm going to do the second derivative. The second derivative gives me 6ax plus 2b. If a point of inflection is at 0, 2, when I plug in 0, the answer is 0. So that must mean b is equal to 0. So then I can come back here. B is 0. So I have 3a plus c. And I can come back here. If it's 0, then -a minus c. And then I can add this up. So a is 1. B is 0. D is 2. What letter am I missing? C. So then we can come back here and plug in 1. And then C is -3. So if I plug in 1 for A and subtract it, C is -3, and you have your answer. 25. Sketch a smooth curve whose slope is always positive and whose slope is increasing. So that means it's increasing and concave up. There it is. B. Sketch a smooth curve whose slope is positive, but the slopes are decreasing. So it's concave down, but increasing. Slope is negative, so it's decreasing, but the slope is increasing. So concave down, so decreasing but concave up. And then the last one, both. It's decreasing and concave down. So do you have a sense of concave up and increasing, concave down and increasing, concave up and decreasing, concave down and decreasing? So here are the 4 different ways you can draw a curve. 26. I can do that on another page. So x squared xy plus y equals -3. Take the derivative. Now this is the product rule. The first times the derivative of the second times the derivative of the first. And remember the hook. So I'm going to factor out y prime. You're left with x plus 1. I'm going to subtract 2x and subtract y, and then I'm going to divide. So I have -2x minus y divided by x plus 1. if you plug in, so for A, it says plug in 1, -2. So that gives you the answer -2 plus 2. So that's 0, right? So A gives you the answer 0. B says find the second derivative. So the second derivative here is the bottom times the derivative of the top. So that's going to be -2 minus y prime minus the top times the derivative of the bottom, and then the bottom squared. And then at 1, -2, because the derivative here is 0, this is 0. So the derivative at 1, -2 is 0. So y prime is 0. Then you just plug in the values. So 1 plus 1 is 2 times -2, which is -4. Here we have -2 plus 4. That's 2 times 1. And then 1 plus 1, 2 squared. So I got -6 over 4 and -3 over 2. What did I do? So this becomes -2, or a negative and a negative is positive. This becomes -2 plus 2. So this is 0. So it's -4 divided by 4. That's where you get the answer -1. C. Does the curve have a relative max min or neither at 1, -2? So it's concave down at -1 and it's a critical number. So that means it's a max because it's concave down and the derivative is 0. So at that point is critical. It's concave down, so therefore it is a maximum. All right, number 27. Use the number line. For the first derivative. So g at x is equal to f at x plus 2. So the derivative at 4 is, so the derivative is the derivative of f. So at 4, the answer is negative. So it's less than 0. 28, the derivative here for 28 would be -2 and the derivative. So at 4, it's negative. But a negative times a negative is positive. And then 29, the derivative here when you plug in 4, it's the derivative at -6, which is positive, which is greater than. So when I plug in 4, 4 take away 10 is -6, and at -6 we have a positive answer. All right, last one, number 30, and we're done. So we have a position at t cubed minus 27t plus 50. And it says, when is the velocity increasing? So the velocity is 3t squared minus 27. That's another way of asking for the acceleration. So for the acceleration, it's positive when it's greater than 0 and negative when it's less than 0. So from 0 to infinity, it's increasing. B, this is what we're looking for. When is the speed of the particle increasing? So speed is increasing when the signs are the same. So for the here, if I would solve this, add 27 divided by 3, so it's t squared equals 9. So at positive and -3, it's 0. If I plug in a negative number, these are the signs. So, where are the signs the same? So from -3 to 0, both are negative. And from 3 to infinity, the signs are the same. So speed is increasing from -3 to 0 and 3 to infinity because the signs match for velocity and acceleration. So therefore speed is increasing. Last one, when is the distance of the particle from the origin increasing? So it increases when the position and velocity have the same sign. So when I look here, the velocity again, you're going to have to take this equal to 0 with your calculator to know that. So I'm going to go menu, I'm going to go algebra, and I'm going to solve that. So I'm going to type in t cubed minus 27t. I was trying to get it done before the bell. Equal to 0. And those are your answers. So there are three answers: -5 point something, +2.306, and 3.644. So where are the signs the same? And if I use that and plug it in terms of signs, it goes negative, positive, negative, positive in terms of that. So the signs are the same, not there, from -5.59 to -3, the signs are the same. From 2.360 up to 3, the signs are the same. And 3.644 to infinity, the signs are the same. So part C was a little confusing, but it's okay. So when the position and the velocity have the same sign, that's what they're asking for. We use our calculator. All right, Mr. G, over and out. I'm proud of you for doing your work. Until next time.